Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we're going to be talking about z-scores. Just exactly what are z-scores and how do you calculate z-scores. So let's jump right into it. All right, a z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. So basically, a z-score, it gives us like a standardized number to be able to compare apples to apples instead of comparing apples to oranges by using the mean and the standard deviation. So it tells us like how far a value is from the mean in terms of its standard deviation. All right, so if a z-value is positive, that means that the data value is larger than the mean, okay? If the z-value is negative, that means that the data value is smaller than the mean. And then if the z-value is 0, that means that the data value is equal to the mean, alrighty? Positive z-value means it's larger than the mean. Negative z-value means it's smaller than the mean. And 0, a z-value of 0 means that it's equal to the mean. So a z-value of 1. So for example, if we have a z-value of 1, that means that our data value is 1 standard deviation above the mean. All right. If it was a z-value of 2, that would mean that our data value is 2 standard deviations above the mean. If it was a z-value of 3, that would mean that it's 3 standard deviations above the mean. Now, if the z-value is negative 1, that means that our data value is 1 standard deviation below the mean, and vice versa. Or, yeah, if it's negative 2, their data value is 2 standard deviations below the mean. So if it's positive, it's above the mean, and if it's negative, it's below the mean. And this is how you calculate the z-score. All right, so for the population z-score, you would do your x, which is your data value, minus your population mean divided by your population standard deviation. And it's the same formula, except for sample, you use the sample mean and the sample standard deviation. The z-score is unitless, meaning it has no units on it, and it represents a mean of 0 and a standard deviation of 1. So your z-score has a mean of 0 and a standard deviation of 1. All right, and this is how you would calculate it. So let's look at an example how we would use the z-score. So in this example, it says the average 20 to 29-year-old man is 69.6 inches tall with a standard deviation of 3 inches, while the average 20 to 29-year-old woman is 64.1 inches tall with a standard deviation of 3.8 inches. Who is relatively taller, a 75-inch man or a 70-inch woman? All right, so if we just look at it and compare, we can see that the man is taller, right? He's 75 inches, but we want to look at it in respect to the average size of men and in respect to the average size of women. So what we want to do is we actually want to calculate the z-score for both the man and the woman. So we're going to calculate the z-score for the man and the woman, and I want to make sure that my writing utensil is on the right color. So here we go. Let's do the z-score. And remember, it's our data value. So in this case, if we start off with the z-value for the man, all right, man up here, our data value would be 75 because he's 75 inches tall, and then we would subtract the mean of the average height for men, which is 69.6 right here, and then we would divide by the standard deviation, which is 3. So we will do 75 minus 69.6, which if we calculate that, we get 5.4, and then divide that by 3, we get 1.8. So the z-score for the man is 1.8. And so what that means is that his height is 1.8 standard deviations above the average height of men, okay? So now we're going to look at the woman and calculate her z-score. And so her data value is 70. Because she's 70 inches tall. We're going to subtract the mean of height of women, which is 64.1. And we're going to divide it by the standard deviation, which is 3.8. So if we do 70 minus 64.1, we get 5.9. And 5.9 divided by 3.8 gives us, I'm going to round it to the nearest hundredth, 1.55. So the z-score for the woman is 1.55, which means she is 1.55 standard deviations taller than the average woman, height of a woman. And so now what we want to do, instead of comparing the actual heights of the individuals, we want to compare their z-scores, because this puts it in perspective to the average height of the man and the woman. And so the z-score for the man is higher, so we would say that the man is relatively taller. So he comes out to be taller, and he also turns out to be relatively taller. And that's because his z-score is higher than the z-score for the woman. All right? So that's how you would calculate the z-scores, and that's how you would use the z-scores to compare data values. If you have any questions whatsoever about this example or about anything in this video, please don't hesitate to put those questions in the comments, and I will respond as soon as I get a chance. Thank you for watching, and I will see you in the next video.